want this part over here. So we have to restrict that. And so we have to say that we only want the values of x that are going to be greater than or equal to 0. And then what it does, just like I said with your trig functions, is it takes off that left-hand side. And now when we do that, it is officially an inverse, and it passes the, it is a one-to-one function. So once again, that's something we can talk about a little bit more in class, but we do have to place a restriction on those quadratics. And here's your quadratic. So we know on quadratics we're going to have a restriction. Now if I give you the original problem, it's already going to have the restriction on there so that it is a one-to-one function. Okay. On part B, we're going to do y is equal to 2x minus 3 over 5x plus 2. Replace the x and y's. Alright, and then we're going to solve. Now, when we solve, let's get rid of the denominator. And you might be trying to figure out, we have two y values. How are we going to get them together? Well, let's see what happens. So it'll be x times 5y plus 2 is equal to 2y minus 3. So then we have to get rid of the parentheses. That's 5xy plus 2x is equal to 2y minus 3. And then we want to get the y's on the same side. So what I'm going to do is I'm going to subtract the 2y to that side, and then I'm going to subtract the 2x to the other side. So I get the y's on the same side. A lot of times we can combine the y's, but in this case we can't. They're not like terms. So how do we get to a single y value? We use the distributive property, and we factor out that y value. And then now we can divide by that 5x minus 2, and we have y is equal to negative 2x minus 3 over 5x minus 2. So we'll write that as the inverse. So the inverse is equal to negative 2x minus 3 over 5x minus 2. And so there you have the inverse of a rational function. And we don't have to worry about rational functions or one-to-one. So we don't have to worry about restricting the domain or anything on that one for rational. So anyways, that kind of covers the algebra side of inverses. And once again, we will talk about this restriction more on example 2a and when you're going to be doing that. And then the last one, this is really for you to do. It kind of goes through the entire process. Graph the function, find the inverse of the function, and then graph the inverse of that. So if you look, this is a quadratic, and what I've done is I've restricted the quadratic to only values that are greater than or equal to 0, so that it is a one-to-one function. So when you go to graph it, you're only graphing the values that are greater than or equal to 0. So to graph this function, if you want, you could do a t-chart, but you only need values that are greater than or equal to 0. So if you plug in 0, 1, 2, and 3, those are the points that you would plot. So at 0, negative 3, 1, negative 2, 2, 1, and then 3, 6. So this is f of x. Then I want you to find the inverse of the function. So we would say y is equal to x squared minus 3. Switch your x and y values. Take the square root of both sides. Now we're not going to include plus or minus because then that would not be a one-to-one function, so we're only going to do the positive. And so the inverse is equal to the square root of x plus 3. And then now you can turn around and graph this, but also remember, if we want to graph the inverse and we already have points, these points just switch. The domain becomes the range and the range becomes the domain. So you don't even really need to graph the inverse algebraically. You already have it. So instead of 0, negative 3, it's negative 3, 0. Negative 2, 1. 1, 2. And then 6, 3. And this is the inverse of that function. And one last thing you can check is, does it look like it's symmetric to the line y equals x? And it does. So you probably know that you did it right. And so that kind of encompasses all the stuff that we have done today with inverse functions. Please make sure if you have any questions on this, you ask in class. And this homework will be a worksheet tonight. Thank you.